let's review. Maybe you had enough chance to think about it at least, so we can maybe set up a template here. So what was our strategy? Does anybody remember enough to get us started on this? Okay, good. We want to get the x squared plus bx, in this case b is 20. We want to get those by themselves. So we're going to push the constant to the other side, right? So we end up with, x squared plus 20x equals negative 104. Right? Now, remember that when we're completing this square, our goal is going to be to add just the right thing to both sides, right? I have to treat both sides equally. But we want to add just the right thing to the left side so that we end up with a perfect square trinomial, meaning a trinomial that factors into a single factor squared. Okay. What was our recipe for that? What do we get for an answer down here? X plus b over 2, right? That was the formula. We know that whatever b is, we're going to get that, if we write that as a perfect square trinomial, we know that x plus b over 2 squared is what we're going to get out of that, right? And the reason we did that, remember, let me just skip back one page here. Here was the pattern we were using. We know that x plus b over 2 quantity squared equals x squared plus bx plus what? B over 2 quantity squared, right?
I don't get that, but wouldn't it still be the same answer even though you put both sides? I mean, the same thing.
Well, okay, but look now, we have to treat both sides equally, but by adding b over 2 quantity squared here, we have turned this into a perfect square trinomial. And the reason we want to do that is because then we're going to end up with x plus b over 2 squared equals some number, and then we can solve it using our isolation technique instead of factoring, right? So instead of a b, what do I really want there? What is b in this equation? 20. So what's b over 2? Good, okay. So let's write it down. Okay, so really, that's a 10, because that's what we get from 20 over 2, b over 2, right? So I'm just adding 10 to this side. Oh, sorry, square. I forgot to square it, though, right? I got to square it. Right? Right, so I'm adding 20 over 2, which is 10 squared to both sides. Everybody with me? Okay? And then that collapses to this. Right? By adding b over 2 squared to x squared plus bx, we get the quantity x plus b over 2 squared. What are we left with on the other side?
4.
4. Well, not 4.
Negative 4.
Negative 4. Okay, and so we did that work so we could write our equation in terms of a single x. And what do we always say about that? If I can point to a single x, I can, what? Isolate it. Good. Solve for it. So there's my single x. What are the steps in order I would use to get that x by itself? Square root, and then add negative 10 to both sides, right? Okay, so if I square root, I'm going to get x plus 10 equals what?
2 plus or minus 2.
Okay, plus or minus, not 2. 2i, there you go, right? Right, because I've got a square root of a negative, so that's going to give you that imaginary unit, right?
Oh, yeah. Okay.
So x plus 10 equals plus or minus 2i.
Wait, how did you get the I though?
Because when I square root both sides, I had a negative 4 over here. So I'm taking plus or minus the square root of -4. Remember what our rule is. Whenever we see a negative under a radical, under a square root, that means we just pull that out as an I.
So whenever you square root a negative number, you get that.
Yep, because, and the reason we're doing that is because remember, the square root of -4 is really the square root of 4 times the square root of -1, and that by definition is I.
Yeah.
Okay? But we don't have to write it that way. We can just go right from there to there. Okay? Then the last step you told me was just to add -10 to both sides. Remember what our rule is for that. We always want to put if we're adding a number to both sides and we have a plus or minus on one side, put it in front of the plus or minus, and then you get both your solutions at once. Okay? So what do we get then? Well, we get for our answer, x equals -10 plus or minus 2i. Okay? Now I want you to notice something about this. Whenever you get, and this is something we're going to talk more about later in the chapter, but whenever you get complex solutions that have i's in them, they always have to come in complex conjugate pairs. If I separate those two, look what I get. I get -10 plus 2i and -10 minus 2i. Do you recognize those as being conjugates? Because they're the same terms but just opposite signs in between. And we say they're complex conjugates because they have i's. Okay, so complex numbers as solutions, and we'll emphasize this later. We'll really talk more about this later. But just so you have kind of a heads up, because this is a big deal. Complex solutions always, if they have imaginary parts, they always come in pairs like that. You could never get just one of those without the other. Yeah.
So if we answer the actual right,
You'd write both of those separately. Yeah. Okay? Make sense? Okay, let's try another one. Let's try a little harder one. We'll add one more step to it.
Were imaginary numbers not hard enough?
No, that's not hard enough. Actually, do the imaginary numbers even make it any harder? I don't think they do.
They don't make sense. They don't make sense. How do they work in the real world? How do you get an actual number from that?
Okay, but remember our discussion about that. Now the question is, what about these weird imaginary numbers? Don't get confused by the name.
I know it's-
They're not. They're normal numbers, except they just have that. They have that I attached to the imaginary part. Yeah. They're not counting numbers, but they still exist in the complex plane. Okay? You just can't. You don't count with them, but you do other stuff with them. Okay? So let's try another one. Let's try this guy. How about? Okay, if I want to solve that equation now, take a second and just look at that, stare at that, and let's come up with a strategy. So let's talk about this a little bit. Let's put all the phones, and I don't want to see any headphones or anything. Let's take all that stuff away, because I don't. In here, that's strictly verboten. Okay. Okay, so now what's our thinking on this? We got to start thinking strategically. Am I going to be able to, when I combine like terms, am I going to be able to point to a single x right away? No, I'm not, right? Okay, ladies? Up here. So what do I need to do then? If I can't isolate, I'm guaranteed I have to do what instead? Okay, you got to combine like terms and describe that. Where should everything end up in this case?
On the right.
On the left side. On the left side because why? Julie, how come the left side and not the right side? Good, because we want to have a positive number of x squared terms. We want the leading coefficient. And when I say that, you know what I mean. The leading coefficient just means the coefficient of the biggest power of x. That needs to be positive, right? So we'll push everything to the left. Subtract 2x and add 6. And what do I get if I do that?
3x squared minus x equals -6.
Plus 6, because I got to get it, remember, I got to get it equal to 0. And that's, what do we call that form? If I write any equation set equal to 0?
Standard.
Standard form. Yeah, that's an equation in standard form.
Incredibly simplified
Okay.
here and down.
Okay, so now we've got a choice to make. So we can't isolate x. Our leading coefficient is 3. We could try to factor it, but in hindsight, is that something you really want to do? No, that's the hardest alternative would be to try to factor it. And the downside is, you see why now I was telling you that I'm going to show you how to factor this stuff, but we don't do it very often. Because a lot of times, this doesn't seem like a good strategy. We could try to factor it, and it may not even work, right? Do all that work for nothing. So we'll skip that. We only want to factor when it's really easy to do. So for now, our only strategy then would be to try to complete the square so we could isolate x. I am going to show you a different approach also that you may, well, I'm pretty sure you'll probably think is even the easiest, but this is important to know how to do also. So what are the steps then? We have to get this in the form, remember like we did on the last example, we have to be able to get it in the form x squared plus bx equals a bunch of junk on the other side that we don't care about.
Wait,
Right.
isn't it
What would it
bx?
actually be on the other side?
Say it again.
What would it actually be on the other side?
Well, just some numbers.
Oh, okay.
Just some numbers, right? We're just going to store all the numbers on that side, but our goal is to get the x squared plus bx isolated on one side so we can turn that into a perfect square trinomial and write it as a factor square.
Isn't it bx divided by 2 or bx?
That's what we're going to add, but first we got to get it into that form. So Julie, what do you think?
Do you subtract 6 and divide by
Perfect. Does that make sense? Because if we want to get the x squared and the x term on one side combined, I've got to subtract 6 to get the constant away. Then I'm going to have to divide everything by 3 to get that x squared by itself also, right? So I got 2 steps to go through here. And that may end up giving us weird stuff on the right side, but we don't care. It's just going to be a number, right? Just going to be a number. So step 1, I subtract 6. So 3x squared minus x equals negative 6. And then I divide both sides by
3.
3. Okay, now think what that means if I divide both sides by 3. Okay, on the right side, it's pretty simple. I just get a negative 2, right? Now, what's it mean over here? If I divide by 3, that's a common denominator, but isn't that the same thing as just splitting it up into 2 fractions? Everybody see that? This is the very same thing as saying 3x squared over 3 minus x over 3, right? And so on the left side, I'm just going to end up with x squared minus x over 3.
So do you want to leave it in that form or do you want to change it to 1/3?
Either way, I'd say this is probably easier. But you know, what is b here? It's not 1/3, it's negative 1/3. Everybody see that? Because that's the number that's being multiplied by x, right? And on the other side, we said, well, that's pretty simple. We just have a negative 2. Okay, so now we're going to play our game. Now we know that we need to add to both sides b over 2 squared, right? Whatever number I'm adding squared there, I'm just going to get x plus that number squared on the bottom, right? Well, what's b? Negative 1/3, so let's write that down. So if b equals negative 1/3, then b over 2 is what? Dividing by 2 is the same as multiplying by 1/2, right? So yeah, it's just going to be negative 1/3 times 1/2, which is negative 1/6. So b over 2 equals negative 1/6. So that's the number that's going to be squared, right? But I have to add to both sides. I can't just add it to this side. I have to add it to both sides. So what is negative 1/6 squared? Well, isn't that, I mean, that's squaring a fraction's no big deal. I just square the top and square the bottom. So it's 1/36, yeah. right? Okay, and on this side over here then, I just get x plus negative 1/6. Well, that's the same thing as x minus 1/6 quantity squared,
But
right?
then wouldn't it be 1/36I?
Okay, well, no, we haven't square rooted yet though, have we?
Oh.
Right, right. So over here though, we do have kind of a mess. Over here we've got not a mess, but we have -2 plus 1/36. We need to add those up into one fraction. So I'd have to get a common denominator, right? Multiply by 36/36. Good, so that's really just -72. And doesn't that make sense? 2 would be how many 36? Well, 2 times 36, 72, right? So we get -72 plus 1 over our common denominator of 36. Does that make sense? Let me write something down that'll help that. So we've got our -2 over 1 times 36/36, right? So we end up with -72 plus 1 is -71 over my common denominator of 36.
Is that simplified?
No, that doesn't. No, we're stuck with that unruly fraction on that side.
Okay, so how do we get the 1/6? Oh, wait, never mind. It's so long.
Okay, so now, Jennifer, now what do we do?
Then we square root.
Square root, good. So now we're gonna square root both sides. Okay, and on the right side, I've got a square root of a negative, so what's that become? I, right. Okay, so let's break this into 3 parts. We've got the square root of -1 becomes an I. Square root of 71, we're stuck with. 71 is a prime number, right? We're stuck with 71. So we get, and on the bottom, square root of 36? 6. Okay, so then, doesn't this just equal,
So wouldn't that just make the number bigger then?
what do you mean?
It's a fraction. If you're to make
But that's a big
36,
fraction.
you make it bigger.
The fraction is.
Yeah, I know.
I'm not following.
Okay, so 71/36 is basically 2 over, basically 2, or near 2. If you just square root it and make 36 6, that 2 becomes.
No, it's about the square root of 2, which is about 1.4-ish.
But if you're making 71/6.
It's not square root of 71/6. Oh, right. Okay, so then what do we get on this side? The square root undoes the squared, right? So we end up with x minus 1/6. Then on this side, we have to include a plus or minus, right? Can't forget that. We're gonna get our plus or minus the square root of 71/6 all times I, right? Yeah. You know, it doesn't really matter. A lot of books do that. Now, you guys are going to be inputting this. You guys are going to be inputting this into an equation editor in Moodle. And so when you do that, you don't really need to worry about it because it draws it very clearly, and you can see that the I is outside of the radical, and it's fine. Doesn't matter, in other words. Okay.
So, imaginary numbers, like, how do they work? Do they work in real life, or what do they even do? Like,
Well, were you here for that day that we went through all the stuff with the pipe straightening out and all that stuff? Okay, you might want to go back and look at that video because we talked. They play a huge role in science and engineering and mathematics. They're just not for counting, but they're good for everything else. In fact, a lot of what you do in physics and engineering, it involves these complex numbers with imaginary parts, and they have important meanings. They're just different from what you've used in the past, but no less important. It's a bad name. They get a bum rap because of the name imaginary, but they're not like they're truly imaginary. They're just different. Yeah, they exist as much as any other number does. Okay, so then what's our answer?
1/6 plus or minus.
Yeah, good. We're just going to add 1/6 to both sides, right? So we get for our answer.
Obviously, it's like you get one answer or the other. Piece of it.
plus or minus.
Yes, that means like the equation is gonna be one or the other. Be light or down.
Okay, so we got two answers there, right? We have to just enter them both separated by commas. Doesn't matter what order, right? Notice once again though, those are complex conjugates, right? Does that make sense? In the first complex number, if we write complex numbers in their standard form, which is just a plus bi, in the first number, if we take the plus sign, a is 1/6, and b is square root of 71 over 6, right? In the second case, a stays the same, but b becomes negative the square root of 71 over 6. Right, so we get this a plus or minus bi. Those are the complex conjugates. Okay, they always have to be that way. Right? Make sense? Not a big deal. I mean, it looks pretty hard at first, but if you think about this, all we do, the strategy is pretty straightforward. We just have to get the x squared and the x term by themselves and then do our little trick. Okay? Now there's one more look here though that I got to show you because you're going to get some questions like this. Joey, but Dad, what are you doing on there? Okay, well, let's not do it now. All right, so what about this? What if I asked you to put a function in vertex form? I want you to take a quadratic function in general form or standard form and put it into vertex form. How could you do that? So we're starting with, for example, y equals, well, let's pick a hard one. How about, we'll just jump right into a hard one.
Wait, you can't do that. No, no way.
Okay, so there's our function in standard form, right, or general form. Ax squared plus bx plus c, right? Okay, we good? So if I want to put this into vertex form, think what vertex form looks like. Vertex form just looks like y equals a times the quantity x minus h squared plus k. You see that that's connected to this trick we're doing? Because all we're trying to do is write this in terms of a perfect square trinomial factored, right? So we really get another free important concept out of this. We can, by doing the same trick, only instead of just getting a number on the other side, we're going to get y combined with some numbers. By isolating on the right side this time, x squared plus bx, and just having a bunch of other junk collected on the left side, we can do the same trick, right? So what do we do then? What's the stuff we need to collect on the left side? On the right side, we got to get this down to the x squared plus bx. So what's the first step? Well, we can't get rid of y. We're stuck with y is going to be in our answer. We want y to equal the same function but written in a different form. By completing the square, we'll write this in vertex form. But in order to be able to complete the square, we got to get rid of some stuff from the right side. What's the first thing we get rid of? Subtract 1, right? So step 1 would be, we get on the left side, we just get y minus 1 equals 3x squared minus 12x, right?
So the equation in red is the vertex form?
Yes. Yeah, that's what we're gonna, by completing the square, that's what we're gonna end up with. So step 1, we get rid of the 1. Now what? This is general form, right, or standard form, yeah. Divide by 3, right? Divide both sides by 3. Yeah, this time it's gonna work out well, isn't it? Yeah. So on the right side, if I divide both terms by 3 separately, what do I end up with? First term would be x squared. Everybody agree? 3x squared divided by 3 would just be x squared. What's negative 12x divided by 3? It's negative 4x. Okay? Now on the other side, I know this is going to look a little strange because we've got this y combined with all these numbers, but in the end, all we're going to do when after we complete the square is just move those numbers back to this side and get the y by itself again. Okay, think of it as just holding on to those extra numbers for us while we do the work of completing the square, and then it'll give them back to us. So on this side, we're just leaving this alone for now. It's the quantity y minus 1 over 3, that's fine. But now, to both sides, I need to add just the right number to complete the square, right? So I'm gonna add some number squared, right? I get some number in here, which is what? What's b?
-4.
So what am I adding up here then? -2 squared, right? To both sides. And the reason I'm doing that is because then that has to factor into x
Okay.
minus 2 quantity squared. Now, does everybody see that? That's really the trick. You see that, you get this whole section. Right? I gotta add b over 2 squared here as my constant to get the quantity x plus b over 2 squared. That's exactly the amount I have to add to these first two terms, right? To these guys. That's the exact amount I have to add to those first two terms to create a perfect square trinomial that factors into a single factor times itself. Right? It's always b over 2.
Wait, do we not have to do the?
And we have to do it to the other side too, don't we? So what is -2 squared? 4. Yeah, so we gotta add 4 to that side also.
Okay, so,
Because we gotta keep the equation balanced.
never mind that, I never got it, I'm just like, I spaced out for a moment, it's like, yes.
He's confused with the studies BX, I mean, B divided by 2, think.
I got it.
Okay? And it takes a little practice to kind of get this process, sort of ingrained, but once you do it a couple times, you got it. Now on this side, notice we've got this y that we're gonna isolate. The quantity y minus 1 over 3 plus 4. Now we completed the square. Now all we have to do is just isolate y. In order, what are the 3 steps we'll do to isolate y? First we subtract 4, good. Then we multiply by 3, then we add 1, right? That's it. And it's not a coincidence that those are just the opposite, it's in the opposite order of the first 3 steps we did, right? We're just undoing those first 3 steps. Right? Isn't that cool? Okay, so let's watch those then. So y minus 1 over 3 equals the quantity x minus 2 squared minus 4. Multiply both sides by 3. So if I multiply this side by 3 and that side by 3, those cancel, right? And I get y minus 1 equals, now on the right side, multiplying by 3 means I have to distribute to both terms, right? So what do I get on the right side? Good. Good. Last step, add 1. You got it. So then we get y equals 3 times the quantity x minus 2 squared minus 11. That's vertex form, isn't it?
Yeah, hey, it's not imaginary, it's
Right.
something we can count.
Yeah. Okay, so what are the coordinates of the vertex? So where's the vertex? H and K. What's H? 2, not -2, +2. Good. +2, -11. We got it. What about that? Right? Make sense? Okay, now here's the coup d'etat. That's everything we got to know from that section. But here's how we can, and you got to pay real close attention to this. This is huge. I've been waiting for this. This is the fun part. Okay, so now what we're going to do, I want you to see this is how we can take a process, and if we apply that same process we just did, right, for either solving an equation or writing it in vertex form, really it's the same process. If we apply that to a completely general case, we're gonna apply it to a case where we haven't specified A or B or C. If we solve that equation in that case, aren't we coming up with a general solution that's really we could think of as being a formula, right? You see what I'm getting at?
Somewhat.
No.
Okay, so now here's my point. If we want to solve the equation, ax squared plus bx plus c equals 0. If I plug in specific values of a, b, and c, I'm solving a specific problem, and that answer is only good in that one case. But if I don't plug anything in for a or b or c, and I solve it in terms of a, b, and c, then do you see that what I'm getting back is a completely general solution? And whatever the values of a, b, and c are, I could just plug them into the solution and get answers. Isn't that cool, right? So let's try that. Now,
Like 3% of
now what are the steps we'd go through here? I gotta get the x squared plus x term by themselves. So first I would have to do what? Subtract c, because remember, a, b, and c are just real numbers, right? So we're just gonna subtract c. So step 1 leaves us with ax squared plus bx equals negative c. Okay, now what?
b plus b half squared or half of b.
No, I can't do that yet. I gotta get, I have to have x squared by itself. Divide by a, right? Okay, so if I divide both sides by a, I'm gonna do it this time I'm gonna do it like that. Instead of writing it as a common denominator, I'm just gonna divide each term separately, right? And on this side, I just get negative c over a, right? Okay, so algebraically, those cancel like I wanted, and I end up, after 2 steps, I end up with x squared plus b over a times x, I'll write it that way, equals negative c over a, okay? So now this is a little bit confusing, because now when we say what is b equal to, we're talking about a different b than just this one, aren't we? Right, we're talking about b, what we mean by b is what's the coefficient of x. So what is what we used to call b? It's actually, in terms of our original parameters, it's b over a, right?
Yes.
Okay, so then I'm going to do the same trick though. I'm going to add to both sides, I'm going to add, so what would be half of that then? If my b looks like, what we used to call b is b over a, what's half of that?
b over a.
Well, okay, but we want to write no decimals.
Times half.
Times 1/2. What's 1/2 times b over a? 1/2 times b over a. If I multiply straight across, it's b over
B over A.
2a, right?
Oh, which is
Okay.
our thing,
Yeah,
which is equals x.
yeah.
That's,
Which is
How about that?
confusing.
that's.
So I'm going to add b over 2a quantity squared to both sides, right? Okay,
Right.
okay, right?
Right.
Now, what is that? So if I actually square that out, I'm just squaring the top and squaring the bottom. So the top would be just b squared. What's the bottom squared? The quantity 2a. Yeah, if I square 2a, that's actually 2a times 2a. That's 4a squared, isn't it? No, 4a squared. 2a times 2a would be 2 times 2 is 4. A times a is a squared, right?
Us and learned everything squared. I don't.
Okay, agreed?
Learn.
Okay, now, the reason we did that, remember, is so we could write this, we could complete the square on the left side. So on the left side, all of this stuff conveniently condenses into what quantity squared? X b over 2a, right? So I get x plus b over 2a squared equals, I'm going to write this in the other form, how about, so we put the, I'm going to put this term first, so we put the positive term first. That's all I'm doing, is just commuting those two. So we end up on this side with b squared over 4a minus c over a, 4a squared, you're right, 4a squared, good, okay? Right? Okay. Let's go ahead and simplify this side while we're at it. If I wanna add up those fractions, I need common denominators. What's my common denominator gonna be?
A,
Not a. I've got a 4a squared here.
then.
4a squared, right? That's the least common multiple of these denominators, right? So I need to multiply this one top and bottom by what?
4 squared, or no, 4x.
4a, right?
Yes.
If I multiply top and bottom by 4a, 4 times a is 4a squared, right? Okay, so now let's see what we got. Now we've got the quantity x plus b over 2a squared equals b squared minus 4ac over 4a squared. Right? Okay. All right, so we're getting there, right? All we got to do now to get that x by itself is what?
Can't you simplify it?
No, I can't simplify that. I'm stuck with that. But what do I do to get the x by itself? First, focus. What do you do first? To get the x by itself. These are just numbers, remember? Square root, right? Square root, and then I just add negative b over 2a to both sides, right? Okay, so we got to finish this. Focus here real quick. We can review this later, but look what we get. If I square root, it undoes the squared, and I get x plus b over 2a equals plus or minus the square root of b squared minus 4ac on the top divided by the square root of 4a squared. But what is that? What times itself is 4a squared? 2a, right? Right? Does that make sense? If I square root the bottom, the square root of 4a squared is just 2a, right?
Which we know because we did 2a squared, which is 4a.
Yeah.
Oh, yeah, okay.
Right?
Yeah.
Okay, now last thing to do is just add negative b over 2a to both sides, and we got our answer. So our answer is x equals negative b over 2a plus or minus the square root of b squared minus 4ac over 2a, common denominator. And this leaves us with the quadratic formula, which is this. X equals negative b plus or minus the square root b squared minus 4ac all divided by 2a. That's the quadratic formula. I will play you the song
Oh my god.
tomorrow if I'm here, Wednesday if I'm not, and you'll never ever forget that for your whole life. Hearing the song 3 times in a row, which I will make you listen to. Yeah.
But isn't b squared in the rest of the
No, it doesn't, because the b squared is a term that's being, right? I can't cancel it because it's not a factor. Okay?
Is it a rap song?
No,
Yo.
Not really.
This is what I figured.